Hi everyone, welcome to Naturally Immune for Life. Hope you're all doing well, and thank you so much for your time and for joining me today. Today we're going to talk about immune tolerance and the importance of the sugar galactose in regards to tolerance and infant brain development and your immune system. Before we went over autophagy, and then we discussed the importance of oral natural immune therapy and one of the colostrum-based drugs on the in trials or on the market. I'm not sure quite where it is in terms of development, but it is for the treatment of IBD, colitis, and possibly chronic gut inflammation. And the importance of that is the infant eventually needs to establish tolerance and to keep their immune system in homeostasis and to keep their defense mechanisms in top shape. So, while your immune system needs galactose, the brain sugar behind immune tolerance. Your immune system is your body's defense system, constantly deciding which cells to protect and which ones to destroy. This ability to distinguish friend from foe is called immune tolerance. Without it, your immune system can attack your own tissues, leading to chronic inflammation and autoimmune disorders. Surprisingly, a little-known sugar called galactose, found in milk, plays a crucial role in supporting this vital function. We're going to explore how immune tolerance works, why galactose and human milk oligosaccharides are so important, and what happens when this balance breaks down. So, what is immune tolerance? Immune tolerance is the immune system's ability to avoid attacking the body's own tissues while still defending against harmful invaders like viruses and bacteria. It works through a network of specialized immune cells such as macrophages and T helper cells, which communicate using chemical messengers like interferon. If you hear that, that's my husband filling his glass with ice. That was in the last video too. And I was wondering what it was. Other important transmitter immune cells include dendritic cells, regulatory T cells, and natural killer cells, all of which help coordinate the immune responses and maintain balance. When immune tolerance is functioning properly, your immune system knows which cells to leave alone. This self-regulation is essential to avoid autoimmune conditions like lupus, multiple sclerosis, or inflammatory bowel disease. But when the communication between immune cells is disrupted, the system can go haywire. The role of galactose in human milk oligosaccharides and immune health. Galactose is a simple sugar that makes up half of lactose, the natural sugar in milk. The other half is glucose. While galactose is often overshadowed by more commonly discussed sugars like fructose or sucrose, its functions are far more important than many realize. Galactose helps label cells with specific glycoproteins, acting like name tags so immune cells know which cells are part of the body and which are threats. It supports immune tolerance by guiding the immune system's pattern recognition, essentially helping it to see clearly. In infants, human milk oligosaccharides, complex sugars which are rich in galactose, play a foundational role in shaping gut bacteria and training the immune system from birth. These HMOs feed beneficial microbes, promoting healthy gut flora that helps establish immune tolerance early in life. This connection between galactose, the microbiome, and immune signaling continues to matter into adulthood. Galactose is an immune-supporting sugar. This simple sugar is 1/2 lactose, the natural sugar found in milk. Lactose is made of glucose and galactose, no fructose involved. Unlike table sugar, sucrose, lactose has been shown to offer many health benefits. Galactose is sometimes called the brain sugar because of how important it is in early brain development, but its benefits go far beyond infancy. It supports It supports long-term memory formation, enhances wound healing, decreases inflammation, improves calcium absorption. It supports communication between cells, and it inhibits tumor growth, especially in the liver. When tolerance fails, certain therapies, especially immune checkpoint inhibitors used in cancer treatment, can disrupt immune tolerance. And it's not just because of the type of drug they are, but some of these are commonly known as MAB drugs, monoclonal antibody drugs. These drugs are designed to remove the brakes from the immune system, allowing it to attack cancer more aggressively. However, in doing so, they can also lead to a dangerous condition called checkpoint blockade toxicity. Checkpoint inhibitors block specific proteins that normally keep immune responses under control. When these are removed, the immune system may become overactive, attacking not just tumors but also healthy tissue. This leads to autoimmune-like side effects, including skin rashes, colitis, hepatitis, and endocrine issues, such as affecting the thyroid and adrenal function. These complications mimic autoimmune diseases and are now recognized as a unique form of immune dysregulation triggered by treatment, a clear example of what happens when immune tolerance breaks down. But it's important to realize that immune tolerance has to be established. And another thing, part of these treatments is that they target the systemic immune system, mainly by injections, and that is why WHO repeatedly recommends that all treatments be orally administered, because it works through the gut and lymph tissue immune system, and it's much safer, and it does not lead to malignancy or increase the risk of cancer like we discussed last time. So this is part of how that dysregulation gets triggered by treatments. So not only does it have to be established properly, you can also induce tolerance by targeting the systemic immune system with injections. And that's why WHO recommends repeatedly that all treatments be orally administered. So why tolerance matters for autophagy and immune resilience. Beyond identifying threats, immune tolerance is tied to autophagy, the body's process of cleaning out damaged cells and recycling parts for repair. When immune tolerance is functioning, autophagy runs smoothly, helping reduce chronic inflammation and supporting long-term immune health. Disrupted immune signaling, whether from checkpoint inhibitors, poor nutrition, or missing key molecules like galactose, can impair autophagy. This leads to a buildup of cellular debris, higher oxidative stress, and increased risk of chronic inflammatory conditions. Galactose plays a supportive role here by helping immune cells recognize what to eliminate and what to preserve. It guides autophagy and immune function in the right direction. And there are other things that do that too, but this is just one. Galactose may be simple, but its role in immune health is anything but. From guiding immune tolerance to supporting gut health, cellular communication, and autophagy, this brain sugar is a critical and often overlooked player in your body's immune defenses. Whether through the natural lactose in milk or the HMOs found in breast milk, galactose helps the immune system stay balanced and focused. In a world of immune challenges, understanding and supporting tolerance isn't just helpful, it's essential. And there are people, the only people who cannot tolerate galactose are those with galactosemia. So if you have that condition, this website and this channel is not for you. It would be very dangerous for you, and you have to avoid it. So galactose in infant brain development. Galactose, a component of lactose, plays a crucial role in early brain development. It is a building block for glycoproteins and glycolipids, essential for forming neural connections. These compounds contribute to the structure and function of the developing brain. Additionally, galactose is involved in the synthesis of myelin, the protective sheath around nerve fibers, which is vital for efficient nerve signal transmission. Human milk oligosaccharides and cognitive development. Human milk contains various oligosaccharides, including those rich in galactose, which have been associated with cognitive development. Studies have shown that higher concentrations of certain HMOs in breast milk correlate with improved cognitive scores in infants at 24 months of age. Galactose metabolism in neonatal brain cells research on neonatal mouse brain cells indicates that galactose can be utilized for synthesizing sulfatides, components involved in brain development. While galactose is less efficiently metabolized than glucose, it does not exhibit toxic effects and contributes to essential biosynthetic pathways in the brain. So another reason this is crucial is regarding injections and not breastfeeding. And which came first, the chicken or the egg? Well, chicken comes first. And the chicken is improper gut development, which will definitely lead to problems when your immune system cannot see properly. And that makes injections, while already being quite risky, it makes them even more risky. So that's it's not an either or, because when the non-breastfeeding rate is 90%, anyone who understands this science can understand what is likely to happen. And it could happen sooner rather than later, but it most likely will happen. So galactose in GC-MAF. Galactose plays a key role in making GC-MAF a powerful immune activator that helps activate macrophages. the cells that destroy harmful invaders. To create GCMAF, GC protein, a serum protein, also known as vitamin D binding protein, is treated step by step with two enzymes, beta-galactosidase, which removes galactose, and sialidase. Yeah, I'm going to say it that way. This precise removal of sugar molecules activates the protein, turning it into GCMAF. The result is a natural immune support compound with no known side effects in humans. This method, developed by Dr. Nobuto Yamamoto, shows how galactose-related structures are central to immune signaling and macrophage activation. And then I'm going to repeat this again. Milk, a postnatal imprinting system stabilizing FOXP3 expression and regulatory T-cell differentiation. Accumulating evidence underlines that milk is a complex signaling and epigenetic imprinting network. This is another part of it that promotes stable FOXP3 expression and long-lasting TREG differentiation. I should say what we just discussed above is another part of it. Crucial postnatal events preventing atopic and autoimmune diseases. And that is from Clinical Translational Allergy in 2016. So, okay, everyone, that's tolerance. You need tolerance for your immune system to see properly and know which cells to attack and which ones not to attack. And when tolerance breaks down, all kinds of bad things happen, like endocrine disorders, hepatitis, colitis, skin rashes, and other autoimmune side effects. So this is why you have to understand tolerance, and that tolerance has to be established as part of proper gut development, and it can break down at any point in life, specifically with certain treatments that target the systemic immune system via injections instead of the safer and more preferred route of recommended by WHO that all treatments be orally administered. So, okay, that's just another small part of the picture. And next week we'll continue on, possibly with the malnutrition role. Not quite sure yet, but we'll continue on until everyone understands it. Okay, everyone, and more importantly, how to correct it. And that's with natural oral immune therapy, which helps reboot the immune system and rebuild the immune system as Mother Nature did when you were as close to Mother Nature as possible without having to be pre-breastfed, which isn't possible. So it's helpful for everyone, and that includes the elderly, whether they were breastfed or not, because by the time you are 62, this optimal immune system function begins to break down. So, okay, everyone, we'll see you next time. You have a great day and a great week. And thank you again so much for your time. Bye.